Thank you for joining us. We are going to, I don't know, answer your questions. Yeah. We decided to get out here and just whatever questions you got, ask them. Developers.google.com/live. And we have a bunch of questions already. Paul Irish.
Paul Lewis.
Adi Osmani.
Eric Beidelman.
And so we just...
Yeah, let's go. Let's get going.
Great. I asked a question. How can I debug?
We're starting off with your questions by taking his question.
Yeah, that's probably pretty good.
That's how we roll.
How can I debug poor performance with CSS transforms?
Because this has come up, right? We've seen a few sites recently, which have had this problem.
Yes.
And yeah, go on. You had a specific one you wanted to show.
Yeah,
right?
yeah. So I'll show this. I'm gonna just share a little bit of this site. So this is a project, really cool kind of design for a site where you can kind of scroll out, zoom out, and get this overall view. And it's pretty cool, but one of the challenges is that it might be a little bit hard to see over video, but it's a bit janky in this transition. So I'm just going to bring up the DevTools timeline, and it looks like they have a media query to kind of change layout, so I'm going to undock this to get the full view. Let's see, we'll just kind of bring this down here. Command-E to start recording, and I'll click in again, and then zoom out.
Oh, that was painful. That is painful. All
right, so stop recording. Now, you can see here we're busting out our frame budget pretty considerably. And if you take a look at what operations we're spending time in this range.
I'm seeing a big green bar.
You seeing that?
Yeah, I am. You know, and I get funny about this because the paint's a thing, right?
Yeah.
Paint profiling, paint bottlenecks are a thing.
Wow.
1.86 seconds.
Yeah. Wow.
So what? Because we're aiming for 16 and 0.6 milliseconds. So we're kind of blowing that a lot by 10.
So there's a lot of time spent in Paint.
1,000.
And so the site itself is actually using CSS transforms to make this happen.
Okay.
So we were talking to the developer behind the project, and he said, we were experimenting with the CSS blur filter, but it didn't totally work. Or he's like, we don't think it's that.
Yeah.
And Paul and I were like, we think it's that. Blur is not hardware accelerated.
It's just very expensive to do because you have a convolution filter that steps over every pixel and has to kind of work out its nearest neighbor and all this kind of stuff. So doing that across a big area, it's like that's a lot of pixels that need to be processed.
Right. Most CSS filters perform extremely well.
So the other ones are hardware accelerated, yes? Or no?
The other ones are accelerated.
Yeah.
This changed over the last 6 months. 6 months ago, that was the case for none of them. Now they're all accelerated, so that means that with the work on video content, all content, they're super fast.
Even so, even if they're accelerated, it's a relative measure.
Right.
So.
So one thing that we did, we just went into DevTools sources and we looked for blur and toggled around. Actually, you know, we because paint. Okay.
Paint's the issue,
man.
All right.
It's always Paint.
Because Paint, we come over into settings and we want to turn on continuous paint. And so I'll turn that on. And what that gives us, dock back up, is up here in the top right, I have the amount of time. So it's just continuing to paint the page nonstop. 900 milliseconds per paint. A long time.
Yeah.
That's close to 16 milliseconds, right?
Yeah, it's pretty close, mate.
That's a lot.
Yeah, that's as near as makes no difference, really.
Yeah.
So now that we have that going, we can try some different things and we can see what affects this. So let's say I hide the entire page. I just select the body and hit H. Oh, it's still checking. Still there.
Oh.
Interesting. How about hide HTML?
What?
Curious.
Wow.
You know, it's visibility hidden. Visibility hidden doesn't remove it from the render tree.
No, true. Display none would.
Yep.
But visibility hidden doesn't. Hey!
Ah, faster.
Yeah.
Good. Okay. That's good. But now that we know what's going on, we're so cute. All right, but we did have this tip that was blur. Let's take a look for blurs. There's this one. I'm just going to try deleting it.
So I have a question. Did you guys just decide, like, start looking for stuff, or
Yeah.
was that a usual suspect, or like how did you go about like discovering that was blur?
Well, in this case,
was it obvious?
The developer actually kind of said, "Hey,
I'm using
there's a
blur."
blur, there's a blur, but we don't think that's it."
It's your first contact.
and
so,
we're like, it is it.
so actually, it was a shortcut.
Yeah. So
Most of the time, it's hard.
A
right?
lot of times, you'll want to walk through the DOM and hide some different stuff, and
So it's very much a
and try and narrow down where in the
Trial
DOM the cost
Yeah,
is.
it's like an iterative thing because you start probably hiding big elements and just kind of going, okay, when does this get fast? And then when you find the element, you start digging down and then you start trying to find individual styles and just going, oh, okay, in this case it would have been the blur, and so but it can be quite a slow process, especially if your DOM's big or you've got a lot of different styles at play. It can start to add up. So
Yeah. Okay, that's that. Let's move on.
all right.
Next question from Simon Owen asks, in the DevTools timeline, is there a way to sort order by what's causing the biggest performance hits?
No, not yet.
No, not yet.
But we're looking at ways that we could make that more obvious so that you know how you spend your time inside a frame.
Yep.
So, because it can be quite difficult to parse sometimes when you're like, oh, how big amount of time was this in a single frame? And yeah.
Yeah, right now we're experimenting with a view inside the DevTools where for a timeline, you record a timeline and you can kind of get a summary overview for all the operations that happen inside that time frame. Just like summarize it in a small little graph. Tell me that my biggest bottleneck was paint, like what we just saw, and JavaScript only contributed this much, or maybe there was a lot of layout thrashing, so I spent a lot of time in layout. But we're experimenting with kind of what is the best way to highlight some of that, and hope to bring it soon. Yeah.
Why is the mobile web slow?
Great.
It's a good question.
It's a loaded question.
It's a very loaded question. Is the mobile web slow?
There's only one reason, right?
Oh, there's only one reason.
No, there's
No.
various reasons, right?
Go on. Why did you say there's only one reason, Eric?
Well, the browser's more than it's a complex engine, right?
Yeah.
Like you're dealing with performance, you're dealing with paint, you're dealing with JavaScript, you're dealing with images, network, and you condense that down to a CPU that is from 1993, and you have issues.
Is a challenge that developers often think that the complexity of what they're creating on desktop is just automatically going to translate on
to
mobile.
mobile.
Right.
That's what people
I
say.
think the reason this kind of has come up, though, is there was an article that's come out recently that basically said the reason the mobile web apps are slow is JavaScript. And think, as Eric said, there's so much more around a browser that is just not JavaScript. It's not a thin wrapper around a JavaScript engine. It's doing tons of stuff. And like you said, it's running on constrained hardware often for mobile web, right? So,
Paul, on that question, so you've been taking a look at a bunch of the different top sites recently, trying to figure out, what are their major performance bottlenecks.
Yeah.
How often has it been JavaScript? Because I imagine it might be other stuff, right?
there are times it can be JavaScript. That's one thing to say. If you're doing something that is, say, image editing or something along those lines, you or a game, you would expect it to be JavaScript, right? Because that's the thing that is running often. But for most sites and web apps, no, it's not.
Right.
Most of the time, it's going to be paint or layout, especially if you do something like thrashing. But it's more a case of laying out the actual site or animations or those kinds of things. Especially if it might be triggered by JavaScript. That's the other thing to say. But it's not that JavaScript itself is slow. It may just be that you triggered an animation with JavaScript. So it's kind of easy to confuse it. But for the most part, it's almost like zero in the kind of meme terms for how often it's a thing.
You have to look at it holistically, right? Like we said, there's different constraints on mobile, and so you can't assume something on desktop is going to work perfectly on your mobile. Like there's actually, we've all seen this, right, when developing mobile apps.
But
it's often not the case at all.
It is possible to build a 60 frames a second mobile web app. It is possible. It's not easy,
Right.
but it's not impossible. And so, is the mobile web slow? Yes, it's possible that it will be slow, but I'm firmly in the camp of it is possible to make it fast.
Yeah.
But you just have to plan for it from the
It's
start.
hard. Yeah, the challenge here is that whereas on desktop, the way that I look at it is desktop's easy.
Comes from free.
I mean,
It's just like,
it's a piece of cake. Come on. And mobile's really hard. So you're dealing not only with weaker hardware, but you also have extremely higher network latencies. And those combination of things mean that your constraints are just really tough to operate inside of. Recently, all of us we're working on some mobile web apps, and Addy and I both made animated GIF apps.
Yeah.
Get user media through to animated GIFs. And I would say the funny thing there is that while using JavaScript to encode an animated GIF, it isn't cheap. You throw it to a web worker, and you can throw it to multiple web workers, and it could be faster. But I would say actually for both of our apps, like while it did take a while, that in my experience that didn't contribute to user dissatisfaction. Like I had the hardest challenges making sure that the UI transitions were fast and smooth and awesome. But the encoding thing where it was just spending time in JavaScript, it didn't detract from the user experience. The harder part was just delivering a responsive, nice thing that loaded fast, worked offline, those sort of things.
You can ask questions. There's the moderator URL at the bottom of the screen, so go ahead if you've got any burning questions, and we'll try and get to
one last point on that question. Is the solution to this the developer should be developing mobile first and actually testing out their layouts and stuff on actual devices from the start?
In my experience, yes. I mean, so Chrome DevTools, the emulation stuff was brilliant for fast kind of iteration, and does this feature even just sort of work, right? Especially when it's Chrome for Android, it's very similar to Chrome Desktop in terms of feature parity. But to actually say, does this thing run well, and does it have any kinks or weird things that I can't just guess from desktop? Then you need the device, and you need to keep checking it on the device. One of the things that I say when I'm speaking to developers is that something like performance, particularly, it's not like a unit test at the end. Am I fast? No. Whoops. Right? This is something you kind of come at from the start, and you say, I'm going to keep checking on the device. I'm going to keep making sure I hit my goals, much as I would do anything else. So I think honestly, my experience was definitely iterate quickly on desktop, but then keep checking on the actual mobile device. And that's hard because not every developer can buy every Android-capable device or every iOS device or any Firefox mobile kind of Firefox OS. So it's difficult. It's not an easy problem to solve, for sure. But if you can, do.
Next question. When is Chrome's font rendering on Windows going to improve? So I asked this. This is something that we've heard quite a bit. And so one of the reasons here why there's been a difference in what you've seen from Chrome on Windows versus Firefox on Windows or IE is that Firefox and IE have used direct write as the text rendering layer inside the browser. Chrome, for a long time, has used GDI. Typekit has a series of blog posts all around type rendering that gets into a lot of details if you want to learn more about this. But this is the core issue at hand, really. And so there's been a lot of work that's been happening leading up to now to kind of lay the groundwork and the foundation for Chrome to adopt direct write. This is the ticket, if you want to watch it any closer. Ticket 25541, direct write support. There's 376 people that started already. You can start it and keep track of the activity.
But its status is started, I noticed.
Started, it's got an owner, and if you go down at the bottom, actually it's a bit hard to see. There's a big kind of blocking tree where you can track all the tickets that are feeding into all this work. So using Ski on Windows, and there's a lot of work happening. So a lot of engineering efforts going into this, and we're excited about seeing font rendering quality improve dramatically.
This does come up a lot, so it'd be nice to see this one shift. Yeah. Next up.
All right. Which effort is going to give more benefit to improve performance? So we can choose that one first. Reducing HTTP requests or reducing bytes of the original sources?
Yes.
And that's your answer.
Yeah.
Do both, right?
Do both.
Yeah.
I mean,
why just do one?
Don't limit yourself.
Even doing both is a fraction of what you could and should be doing, really. Like images, this doesn't address images. We could totally, making sure that you have a proper pipeline to address lossless compression of images, lossy compression of JPEGs, resizing your assets to make them appropriately sized to where you're displaying them, whether it's on desktop or on mobile. These are huge, huge things, and they have to be happening. gzip, for sure, reducing the count of HTTP requests is key. I mean, checking out the waterfall of basically all the network requests that have to happen before your user actually sees anything that's relevant to what they asked for. You want to get those requests out of the way so that they just get their content as fast as possible. And that's hard.
Yeah.
It's tough. But
certainly on mobile,
yeah,
reducing the number of requests is probably the first thing you should go, but certainly reducing, like you're saying, for images. One thing I would say on this, though, is this is very network-centric as a question, right?
Right.
And that's only part of your job, because once it actually arrives on the user's machine, if you're having to resize images, run JavaScript, do a load of work, you still need to make sure that runs well.
So there's also the scrollability of the page. Like when I scroll it, like does it stick to my finger, or is it like chugging along?
There's almost two 60 FPS, right? There's the network one,
right,
before time to glass, and there's the one in-app, which is also critical.
Yes.
There's two different sort of paths there.
I think historically we've very much concentrated on how quickly does this stuff get to the device,
Absolutely.
And especially because things didn't necessarily render quickly or run quickly, and now that we're a few years on, things are much, much better in terms of the capabilities of the devices and the browsers. The network is still hugely important, but also the sort of second part, like you said.
I mean, I've had my Gmail tab open for 4 days, right?
Yeah.
Like, it better be a great 60 FPS in-app experience at all times.
Exactly.
So network, compute, and render apply to mobile.
Oh,
too.
almost like That's how we definitely break things up in Chrome DevRel, is those 3 areas to make sure that we cover both the loading and the running side of every site and app. But yes, to the original question, yes.
Yeah, I'd also point out that making sure that you have robust tooling around this side of things, and I will just recommend mod page speed or Nginx page speed. I mean, you just toss those modules in, and it's going to take care of all the things that you've heard Steve Souders talk about for you. You do a little bit of configuration, and then you update your site however you want to do it, and it's going to make sure it's delivered. All the assets are delivered following best practices.
Right, because you can still upload PNGs and JPEGs, and it will kind of figure out whether it should actually, transcode those over to WebP, right?
Right. Yeah, it's painful for you to have to do drag everything into ImageOptim every single time that you create a new asset and go through that process. And it's much nicer to just publish your actual content and let an automated process take care of things.
We're actually using it for HTML5 Rocks, right?
Yeah.
It's a feature in App Engine 2 that you can turn on. And so we made optimizations originally on the site, but we can do it for free now with page speed. So we don't have to do things like encode images.
That's awesome.
It just works.
Yeah.
And if you have a hard time setting up a build process with image optimization, a few of the other things Paul was mentioning, we do capture some of the stuff in Yeoman. Just gonna
lovely drop in.
Plug that in.
That's good.
Yeoman's got it covered.
Yeah.
For sure, absolutely. All right, next up. Can I live edit JavaScript in Chrome DevTools and reload the page without losing the changes I've made in the JavaScript source file? Yeah.
Yeah.
Yeah. Here, we'll do it right here. We'll do it on this the moderator page. Is this gonna work?
Don't kill the page.
Don't kill the page.
Let's pull up this.
Yeah, nothing could go wrong here.
You don't think so?
No. This is great.
It's a bulletproof.
All right, great. Now, the interesting thing about so live edit, I can make any change in here. So this is minified, but we'll make it work. So clearly, this function x is calling y, and then we return get elements by tag name. And I just really want to mess with this, so I'll just change the class name. Hit save. Command S. Now the definition of x is totally changed, and so maybe I'm going to cause some errors because it's totally no. This is not going to find elements. That's right. Anyways. So the important thing is I just made a change. This is immediately patched up to V8. Kind of a weak demo of this, I think.
It's still nice.
I could do better.
Yeah, okay, but you do this on the fly.
All right, whatever. It's fine. So I can right-click and save this file as, right? Now I can do this and save this back to disk where this file, where this asset came from, and there I get live edit and I get persistence to disk. Another way of doing this is using a new feature called workspaces. For that, you can check out this post, which we just added to HTML5 Rocks just recently. This covers a lot of things that we showed at Google I/O, including workspaces, which is basically a way of mapping a site that's coming over the wire to a local file system folder. And so I can make changes in my JavaScript source. I can have it be patched up to V8. And every time I hit Command S, not only is that patching happening, but it's also persisting to disk immediately. No save as dialog necessary.
That's really nice.
And the really nice thing about this is that you can edit your project and debug and live edit and do all those things at the same time directly inside the DevTools.
Not bad. Not bad. Yeah?
Yep.
Great.
Awesome.
All right. Next up, what do we got? What do we got?
Biggest performance hitters. Yeah.
All right. What are the biggest performance hitters on mobile and tablet devices you see today?
Paint is big deal. It is the big deal. Paint and composite. The idea of, so again, we've kind of got used to on desktop the fact that you can change the look and feel of a page, do it with JavaScript. You can make loads of visual changes and it will just keep up with you. Like you said before, desktop is comparatively easy.
It's a piece of cake.
Yeah. But mobiles have two problems. One is that they're CPU constrained, and then the other side of it is that their uplink to the GPU is often sort of bandwidth constrained. So when you paint, you're going to spend time in the CPU actually painting the pixels in, and then you're going to spend some time uploading those pixels to the GPU for compositing. Both of those are going to be very slow. So all I'd say is profile your sites, profile your apps. You'll probably see big green blocks. You'll probably see purple blocks as well. That's the other thing I often see, which is layout or calculation of styles. And what can you do about them? Don't do them. I mean, it's an obvious answer probably, but there are things like changing opacity or translating items. They are, especially if you do them with 3D transforms, they are accelerated, and they are just essentially moving textures around on the GPU or fading them in and out. And that is often way, way faster than, say, redrawing them. Is obvious again, but layouts, make sure you're not doing layout thrashing, and make sure you limit the tree size for your style calculations and your layouts. So we have a new feature in Canary which will show you the scope of your layouts and the scope of your style calculations. So if you're overdoing it, like changing a class at the root of the document, it may be that you're having to recalculate a lot of style, or you're maybe doing a lot of layout off the back of that. But it may not be a thing for you, so profile it and find out which one is a thing for you, and then fix the thing that's yours.
Yeah, that's an important point to make, which is that there are a lot of layout thrashing. Oftentimes is a big issue.
Yeah.
But for whatever your case is, run into Timeline, profile it there, and find out what is contributing to your specific bottlenecks. Because there are guidelines for sure, but you want to be addressing your biggest performance concern, and it's specific.
I mean, DevTools will tell you all of them. You'll be able to see them pretty quickly if you do a profile. And the other thing is take a look at HTML5 Rocks /features/performance. Does have a good list of articles we've got on. Are you going there?
Yeah, I'm going to go there.
Features performance. And then if you scroll down, right to the bottom for me, the render performance one, if this further reading does actually do a list of a lot of the things, a lot of the kind of common gotchas that you're probably going to see. So take a look at that page.
Also check out jankfree.org.
Jankfree.org. That's actually listed in the further reading of this page as well, so that's great. That's got a whole heap of videos and slide decks and articles that you want to check. So there you go. That's what I'd say is probably the big deal on mobile.
Good. I would also point out image decode and image resize are super costly. Like if you, this happens a lot with the responsive sites where you have like a 600, 400 image, and like you have media queries and it's being resized to fit inside some sort of column. The operation, so the image has to be decoded first into a bitmap in memory. That operation takes a good amount of time, and the larger that the source image is, the larger that decode, of course, takes. And then the image has to be resized, re-rasterized into the destination dimensions. The larger the original is, the longer that's going to take, even if it's going down to 100 by 100.
Yeah, and it's a dependency of paint. So whenever Chrome needs to paint a part of the page and that requires an image, that's the point it's going to do the decode. So it's not going to do them all up ahead of time, because you might not scroll to the bottom of the page. It's going to do it as and when. So that's going to hit, say, the scrolling performance.
So what is a decent strategy for handling images? Is it like checking to see what the largest resolution your user using and having the image be no larger than that? Is it using source set? What is what should people be doing
This is a hard
here?
problem. This is the responsive images problem, and I don't feel like we've got a good answer as an industry yet, personally.
Yeah. So right now, I would say like, so there's first of all, there's the format issue, which is to any browser supporting WebP, you want to be sending those. To any, i.e. 9 and 10 and 11 support JPEG XR, which is a pretty rad format. And so that is far better than just standard JPEG for them. So you can send them those. For everyone else, you want to be using the best, most appropriate format, and you may not, know right up front. So if you have tooling that can, try a few different ones, test it out, and send down the most appropriate thing. Delivering a size of the asset that will not be resized on the client, not be scaled to a new dimension, is ideal. That ends up meaning between these formats and the different sizes that you're going to end up with something like 10, 12, a lot different versions.
Well, if you're feeling lazy, another plug for page speed service, right?
Yeah, right.
It does this stuff for you.
It does do a lot of that. It doesn't do all of it for you.
I think, right format,
but
it'll deliver.
It's a good first step. If you're not doing it today, right?
If you want to be lazy, that's absolutely.
It's a good first step before you kind of really.
Yeah, but I would also say like we're still not there. We don't have the most appropriate image tooling necessary for mobile, tablet, desktop.
It's very difficult as well because like top-end tablets look like lower-end desktops.
Yeah.
Right. So it can be very weird to try and figure this stuff out. Yeah.
Okay. Next question comes from a lovely gentleman by the name of Paul Kinlan. He asked, you want to just, he's in the corner of the room right here.
Yeah. Is it possible to automate UI profile, like performance profiling?
Is it possible to automate UI performance profiling?
Yeah.
On mobile?
On mobile.
On mobile or desktop. So like you made the point earlier on about like, you have to get onto the device and like scroll and test. Is there not a way that we can like not for every single part of the user interface, but some of it test automatically?
So I'll repeat in case anyone couldn't hear that too well. Is there a way so that I don't have to have my phone here and test after every single change that I make that I'm hitting my performance goals? So the state of this is evolving. I think some of the most interesting work in this area has been done by the Adobe Topcoat team. Yes.
Yeah.
So they have a really nice. So Topcoat is a UI library with CSS for components, and one of their goals from the beginning is having something that's extremely fast. So they actually watch how long it takes to paint, one of their buttons or one of their drop-down components, and make sure that as they develop, they don't regress those goals. So I'm going to show you one of the sites that they use to kind of manage this. So this is bench.topcoat.io. And what they've done here is actually they use a project from the Chromium project called Telemetry. And Telemetry goes and runs some of their test pages. And so they can see here, this is the amount, this graph we have, the amount of time spent in layout, the mean frame time in milliseconds. And so this is over a few commits. They're watching for this button. They see a few metrics as they change. And let's see, do I have... Well, there's some good stuff in here. I'm just redesigned, so I'm kind of disoriented. Wow, cool.
Colorful.
Needless to say, they take performance very seriously.
Yeah, I'm so pleased. If you actually look at the topcoat.io page, it's like the bottom corner is like so fast, then it just says performance is our #1 goal, and I'm clapping. I'm clapping them on.
That's the first CSS project that's ever done something like this before.
So I've seen an increasing number of projects starting to use telemetry. I know that you've spent a lot of time with it. Do you want to talk a little bit more about how it works?
Telemetry. It's a Python-based framework. As Paul said, it's part of the Chromium project, and it launches Chrome with with a couple of extra flags, which enable APIs. It then connects, using Python, it connects to the DevTools protocol and basically runs a bunch of tests like scrolling, smoothness, and so on, and uses the extra APIs from those flags to get out more detailed information than would normally come out.
Yeah.
You can also do other things like it can run a trace, so if you've ever seen about tracing, it can do those on the fly. But certainly the kind of information that you normally get from DevTools is available sort of programmatically through telemetry.
Yep.
So that's what it does. It goes through, you can then pass it a list of sites to go and check, and it will step through them. Obviously the top code team have got it running against their own sort of suite of pages, picking out the information they're interested in and storing that. So that's what it's done. It's basically the tool that the Chrome team used to check for regressions from a performance standpoint. So it's available. It's certainly, we would say it's the engineer's tool, if you will. So it can be a little bit interesting to get up and running with, to put it mildly. But if you do, and you have a use for an automated tool like telemetry, then it could be something that you might want to look at.
Are there any open source projects that are using it that I can sort of get up and running with very quickly? Or is it still very engineering focused and takes some work to get up?
I think it's the latter really at this stage. Yeah.
So it's very powerful, but
it's powerful and yeah, a lot of what telemetry is used for is used by the Chrome team for testing its own regressions, and so it's not necessarily very developer friendly right now, and so you're kind of on your own if you start to dig into things, but it is a powerful.
But as you can see what the top code team have done, they've really made it kind of work for the things they're looking at. So it's possible.
And I think we just saw. I just read Slimer.js was announced recently. It's a headless gecko, and so there's an increasing amount of like headless browsers for automated testing. So I'm eager to see other projects do the sort of thing that you're able to do with telemetry and be able to test things like UI performance in like a continuous integration setup over time.
Great. So telemetry is a good solution for trying to get like regression testing into your CI.
It is. It's basically the only solution available for CSS performance regression testing. It is. I wouldn't say it's a good solution because it's not like there's documentation for doing this. It's actually not using it the way that it was intended. But so again, you're on your own. Kind of a big red disclaimer on this one.
There's not that much support for this project as such. It's one of those.
We'd like to improve that story, but we're just not there yet.
Can I have one more question?
Paul Killen with another question.
So this
question. Make it quick because they can't hear you.
Because it goes over the DevTools API?
Yes.
Can we not just provide a lighter weight solution than rather than have this whole telemetry?
Great question. Paul adds, because it goes over the DevTools API, this is the DevTools remote debugging API, telemetry communicates over it. Could we not provide a more lightweight solution?
Or someone in the community?
It's certainly possible.
It's certainly feasible as an idea.
It is.
Yeah.
I feel like I want to get it into my mock test.
I feel like it's good. It's good.
So this is
let's move on.
Lazy web request.
You done with your questions?
Yes. Sorry.
Great. No, they were good questions. All right. Question from Paris. What happened with the SAS source maps? What's planned for Stylus, less other CSS preprocessors? All right. First up, SAS source maps. If you're paying close attention to this, you might have heard something around like 6 months ago. The original implementation of SAS source maps with DevTools used a feature called something dump debug info.
Yep.
Something.
Debug info.
Debug info something. Yep. Spat all these ugly comments into your source and allow you to do line number mapping between your SAS and back to your sources. That's cool, but not that cool. So it was deprecated.
Bye-bye. Okay.
And the new implementation of SAS source maps uses the v3 source map model that is used by like Clojure compiler, Uglify, the standard like JavaScript source maps. It's the exact same JSON source map format. So this has been in Chrome for a while now. And there's support inside SAS, although it's in a pre-release version. They hope to ship out a new version of this soon.
It's 3.3.3?
Yeah. If you are interested into it, I would recommend checking out the Chrome DevTools Revolution post on HTML5 Rocks, where we talk about how to get everything installed and get that up and running. But as to the rest of your question, Stylus, less other CSS processors, as I mentioned, while the implementation has been, well, the feature has used the word Sass, the actual implementation is completely agnostic. So any preprocessor that spits out a v3 source map will work. So if you go to the less GitHub repo, there's a ticket, and there's a lot of activity, and there's already work in a branch on source map support for less. So that seems to be coming along, might not be too far off. And I haven't seen anything for stylus or rework yet, but would totally be supported from day one.
So if there are developers that want to be able to get support for it, they should basically make some noise on those repos?
There's actually already a lot of noise, a lot of plus ones, a lot of people are like, I want this, of course. I mean,
a lot of heat, no light.
Or rather, some help.
There we go.
Actually, there we go.
Be the change, yes.
Patch is welcome. That's how that works, I guess. Yep. All right, next question. I've tested Firefox and Chrome for Android performance. Firefox is faster than Chrome, about 60 versus 30 FPS. With the request animation frame. How can I improve my request animation frame performance, Mr. Lewis?
This is a difficult one to answer because we don't know what you're doing inside the request animation frame.
Yep.
It's perfectly possible that you're triggering something in Chrome, like a layout, maybe doing layout thrashing, something that is just not happening in Firefox, or it could be a paint bottleneck. The thing I would suggest you do is just contact me or just file a bug and let me know about it, and we'll follow up. If there's basically an issue around which the engineers can kind of rally and take a look at some source code, that's very good. Then it'll either will resolve the issue because it's a problem directly in your code, or it's not a problem, it's actually an issue with Chrome somewhere, and we can take a look at how we can fix it going forward. So it's the honest answer is profile it. Use DevTools, profile it, figure out what the problem is. If you can solve it, great. If you can't, then file a bug and we'll see if we can get it fixed.
Yeah, I think reduced test cases are always the best way for engineers on the Chrome team to look at and actually get stuff fixed.
Yeah.
By far the most effective means.
Invariably. Do not fear filing the bug. It's very straightforward and it is very helpful. Yeah.
Heck, we'll even file it for you if you give us a test case.
Boom. Just send it to us.
That's how important it is.
Yeah, that's exactly right.
I'm not signing up for that, by the way.
Yeah, he is.
He just volunteered.
Yeah, he just
volunteered. Send your bugs to me.
All of them. All the bugs.
All right, next question. Are CSS3 substring matching attribute selectors slower in performance compared to using standard classes for everything when we need to select lots of tags on the page? So, yeah.
Probably.
For sure. So this would be like something like a div with a ID like star equals that matches foo, kind of one of those.
You're gonna send it live.
I think this is. It's so nice. There we go. That's nice.
Just one thing about this is be sure that it's actually your bottleneck. Right?
Yeah.
Don't solve this if this isn't the problem.
Right. So this is certainly slower than classes, and that I think would be obvious to everyone. But yeah, it's likely that that selector speed is not going to be a problem.
It's not your thing. Most likely.
The way to check it, you can the CSS selector profiler. So what this does is it looks at it looks at all the selectors that are in your CSS, and whenever there's like a layout, when all the style rules are checked against your DOM, it's looking at how long those matching operations take place. That's it, right? It's not about how much the rules take to process. It's just the selector matching. So you can look at this, but the numbers are all very, very small. It's all fractions of milliseconds, and compared to the sort of things that you'll see in a timeline, it's pretty minimal. Wow.
Well, you're on continuous paint.
Continuous paint, that's why so much green.
Yeah.
OK, cool. Now, in timeline, you may see something. Let me see if I can bring it up very quickly. Turn that off, and anything?
I don't know. What are you looking for?
I'm looking for a style recalc.
No, you have not got one.
Recalc.
Yeah, you do.
Hey-o! You little lonesome style recalc.
Elements affected, 139.
Ouch.
Oh, three 3.5 milliseconds for style recalc.
But that's definitely bigger.
On mobile, it would be about 30 milliseconds.
It would be big.
We can click over it and we can see why that was caused. Oh, we got to get bounding client rect. Yep.
And another one.
Oh, so anyways, my point.
We should make one of those. We should probably wrap
Recalc
up
style.
Yeah.
Recalc style, that operation does capture all selector matching. So if your recalc styles are huge, then it's possible your selectors are slow. But recalc style also is the recalculation of all the computed styles. So it's a lot more than just the selector matching.
Yeah.
In general, probably not your bottleneck.
It's a really key point. This is why we keep saying profile it, because every app is different. Every bottleneck is, there are some common ones, right? We are seeing paint as a thing, but just find out what your actual problem is rather than kind of committing yourself to specific rules. I'm not going to say it, gent.
Say it.
Don't guess it.
It's tools, not rules.
There we go.
Oh yeah.
That's why I came to London.
Yeah, I know. Catch it live in person, in the flesh.
Validated
That's
your
the
whole
one.
trip.
I
mean, that might be your CSS hot path, but that is one hot path in an app, right?
Yeah.
Can't say it enough.
Yeah, really can't. All right.
I think we're done, guys. Anything more to add?
No, I mean, thank you for asking the questions. We're sorry we couldn't get through them all, but no.
Yeah, we'll go in and add responses to all the questions that we didn't get a chance to respond to. So just inside moderator, we'll just add a response. You can check it out there. Thank you very much for joining us.
Yeah. Thank you. Thanks.
Bye.